Alright, I'm gonna give word break 2 another go. Giving it a few goes now, so I know the method, I just don't know the implementation. So we gotta start with, and we get the length of our string, I think. The length of our string, yep. Which is our input. Then we make an array, dp, and that is equal to false. Is this the wrong language? Oh, it is the wrong language. Whoops. Oh, delete this. So we get the length of our string. We make an array and we times it by n+1 because we need a starting, this is just the track where like words finish in this. So like element 2 is gonna become true because cat finishes there, so will element 3 because cats and sand finish there, and dog, and then it'll just, yeah. We're just trying to see all the places that strings can finish throughout the whole thing. So we then set the first element to true. This is for empty strings. Then we need a I loop for I in range S, I think. I should loop over the whole thing. Then we do it for j in range I. If dpj is true, or we can just do if dpj and dpj through to I in word dict dpi is set to true, and then we break, I think. See, this is obviously going to be wrong. I'm just checking if we are getting true, false. Okay, so it is not updating DPI. We don't break. I feel like that shouldn't make a difference though. Does not make a difference. So why isn't this working? Alright, what is going on here? What am I doing wrong? Maybe this length is meant to be more. Let me just print si. See what we're iterating through. Cats and d. So we're not even getting close to the end of it. Why cats and dd? Okay, I'm definitely doing something wrong here. DPI is set to true. DPJ. Hmm. Okay, I'm thinking I'm definitely doing something wrong here, just from the start. So let's just, these should both, this should just print true, false, 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 false. So if DPJ is true and DPJI, I don't understand quite why this isn't iterating through the full thing. I in range of S, cats and, I don't understand why it's not printing the full thing. CATSANDDOG and then one for the start. So CATANDDOG. And then it doesn't loop through fully. Cats and. Ten, which it should be, but it never loops through that. So now we're not even getting the. What? Why is this not printing? So if I remove a print statement, it prints more? Or is it just the editor can't? Oh my god, the editor can't print that much. Oh, that's sad. Okay, that's good. It's not good, but it's good that I know now. Okay, so it's for J in range I print DPJI, view more. But this I actually want is SJI. Cats and DO. Okay. If this prints, it means something else is going on. Okay, so it's not printing. Probably because I did DPJI. That's not good. True, false, 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 true, true, false, false, true, false, false, true. Oh, finally. That's a silly mistake to have spent 9 minutes on, but you know, you win some, you lose some. Then we need to make a backtracking function, which is going to take our index and our current underscore sentence. So the way backtracking works is this term increases until we hit our finished case, and then it will return, and this is the thing that we are building on with our index. So if index equals n, I'm just gonna, if index equals n, because n is the length, which, yeah, okay, then what we do, because that means that the index has got through the whole thing, we take our results list here and we do res.append current underscore sentence dot lstrip, because we need to strip all of the left spaces from it, which the reason I'm doing it like this now is just because I remember that this is an issue later on, because I have looked through this solution before. And then what we do is we return, just get out of the function, we don't need to be here anymore because that means it's all done. Then we have another loop. Now this is what I do not remember at all. So here we need to see if the word is like valid, I guess, if we can actually like build on this. So what we need to do is we need to check that our index should be the starting position, I think. It's either the starting position or the ending position. How is this meant to work? So we go over our list. We eventually call our function and we pass our sentence in. So we have to add a sentence to it. It can't be our starting position. It has to be our end position. Kind of like what we did up here. For I in range, no. But why would we already have our index. So for I in range index, so I is going to be our starting position, index is going to be our ending position. If dpi is true and s I through index in word dict, so this will just be if the dpi is true and s through to I index is in the dictionary, we can do backtrack I, if dpi, or do we want this to be in the range of s and index to be the starting position? Because how else would we bring our I up? I think we need to move index up, so I'm just gonna do in len of s. And then we need to build our current sentence. So our current sentence is going to equal I think these need to get swapped around. And then to make it faster, we do if dp -1 backtrack 0 empty string, and then we can just return res. Okay, what am I doing wrong here? Cats and equal the current sentence, which is nothing, plus a spacebar, plus this, which will get put through. If dp index is true. Okay, so maybe I need to do it as index is the thing that moves up. Range of the index. If dp I and s I through to the index. Oh, I hate this problem so much. I really don't like this problem. from the index is moving up to the end. So it moves, the index is what gets moved up, and this is just equal to the length. Zero, 1, 2, 3, 4, 5, 6. Yeah, okay, so it caps out at 9. 3, 4, 5, 6, 7, 8, 9. So it moves up. The index is true. I vaguely remember having to do this, but I don't know why. Why would I have to add 1? If the index is true, shouldn't this be erroring? Ten. Print S10. I swear this should be erroring. Oh my god, because it's exclusionary when you list slice. Oh, I get it. Because before we were never going to the end of the word because yeah, alright. Because we're slicing, we're not actually accessing that element. And then we're doing here. I don't really know why we're doing the +1 here though either. Because index gets put through, and then if it's equal to the max, we just exit out. Otherwise, we can do add 1, I guess. The reason we do this is we just need to even check if it's possible, because otherwise they're gonna have a whole bunch of like junk test cases, which are just not possible in the time limit. So you need to check here before you call backtrack. This is good to remember. I'm probably not gonna remember this for future, but this is good to remember. I might ask Gemini why we add the +1 and just see if I've got this right. Need to represent substrings ending in index n, which is the n+1th character. The loops need to consider all possible ending indices for substrings, including the very end of the string, since Python's range start stop generates numbers up to, but not including. Okay, that makes sense. We don't include empty words. The loop iterates from the character after the current index, effectively considering substrings starting from index +1. Okay, sure. So just remember to add 1 because we've added 1 for the empty string at the start. Okay, cool. Took 25 minutes, which is whatever, but I think I'm happy enough to call it here and not try this again for a little bit of time, just because it is like, good enough for now, I think, to move on to try a different problem or maybe some other dynamic programming, I think. But awesome. Uh, cool.